Okay, so what we're going to do is, well, let's start by just the basics. Okay, we have math address decoder, which is 7N, and 2J, which is a 138, and then you got a 139. 2J and 7N. Okay, kind of need to make a list of parts that I need to check. Grab this. Let's do this. Okay. Let's do this. 7N, 2J. Okay. That's correct, right? 7N, 2J. Okay. I want to look at a lot of these just simple gating chips first and foremost, wherever I see them in the math. Here's adders and stuff. Those are all, that's all kind of complex stuff that I'm not really. We can always look at the 175 outputs and stuff. But right now what I'm thinking is simple gates. 8N, 3M. 8N and 3M. 8N and 3M. Okay. Just gates. Gate chips. Here's a lot of, flip-flops and whatnot. Here's some gating stuff. Multiplier, accumulator, clock. 8C, 8D. 8C, 8D. Okay. Here's registers. Flip-flop, 8A. Okay. And just some counters here. I guess we can, those are easy enough. 10C, 9C. 10C, 9C. Okay. Matrix processor clock. 8E, 8F. 8E, 8F. And the 161, 9D. Okay. 191s. Here's a flop. 7P, 8H. 7P, 8H. Matrix processor address and data selector control. Well, we have 5E and 6E. 8N I've already got. 5E, 6E. 5E, 6E. Gates, simple gates. And then on this page we have, here's some matrix processor stuff. 5E and 6E, we already got that. And then we have all of these gates here for the instruction strobe gates. 7E, 7E, 7F. 8D. 8D. We already got 8D. 7E, 7F. 7E, 7F. We already have 8D. So let's start with these chips. Just kind of poking around with the little scope there. And check some, how are these signals looking? And then if everything looks good there, then we'll have to start doing some deeper diving into some of the more complex chips. So that's how I'm going to start. It won't take no time to poke around on those chips. So let's do that first. Okay, we got it running. No stars, no enemies, nothing like that. So kind of set it like so. You can see the little scope over there in the corner. And I'm going to start kind of poking around on those chips that we spoke of. Start right at the top with 7N. 7N. Where are you, 7N? Okay, 7N is a 138. So we'll look at the addressing inputs, and they look good. And we have 0 will be enable, 0 enable, and a high enable. Okay, so this thing should have action. We have a high, that's the last bit. Here's the number 1 bit. 2 bit, I see it gets active every now and again. Okay. That one probably just doesn't get activated at all. It's high, low, okay, high. Okay, so this chip doesn't necessarily look bad to me, but it needs further analysis. What I'm looking for is obvious faults. That's the only thing I'm really looking for right now. I'll put it in the back of my mind that this chip looks okay, but it doesn't mean it's okay. It definitely doesn't look flat out bad. There's nothing floating, there's nothing stuck low on there. So moving to 2J. 2J is a 139. So the first one, here's the enable. It is being enabled and it has addressing bits. And let's look at the outputs. Okay. Okay. Alright. And alright. Next. Enable. 2 select bits and the outputs. And that, nothing looks wrong there. That looks fine. 8N. 8N is a 0, 0. Okay. Input, input, output. Okay. Input, input. So this should be inverting this signal. And it is. Okay. Input. Alright. Okay. And should just be low all the time. Okay. That looks good. That looks fine. 3M is a 0, 0. Okay. Input, input. Now based on our 2 inputs, we have that one flashing high. On a NAND gate, you need 2 1s to get a 0. So are those 1s lining up to make a 0? I think so. So we should have an intermittent high going low. See how that, you can see it intermittently going low. If I hit single shot, see, there it is right there. I mean, it's a noisy looking signal. It looks like crap up here. But that doesn't mean it's not good. Okay. A low input all the time means we'll have a high output all the time. Doesn't matter what this one's doing. It's going to be high all the time. And low or high. And we should be basically inverting this signal. And we are. That one looks good. 8C, which is a 08. Okay. 08 is an AND. You need 2 1s to get a 1. So our output should look just like that. And it does. Okay. And our output is going to look pretty much like that, I think. And it does. And this one's not used, floating inputs. Okay, input, input. Our output should look about like that. And it does. Well, that one looks okay. 8D is a 0, 0. Okay, output's going to be high all the time. First input, second input are low, it's going to be high. Yep. Okay, we got a signal, we got that signal, we should have a signal. That looks good. Okay, we got a signal, we got a very busy signal, so we will have a somewhat busy signal. There you go. Alright, signal. Signal. We should maybe get a low pulse, and we do. Okay, so that one's good. Alright, 8A, which is a 7474. This is clear. We're not clearing. We have data. We have clock. We are not presetting, so we should just have signals on the inputs and outputs, and we do. Alright, other side. High. We are not clearing. We got data. We got a clock. We are not presetting. And we just have a flop signal. Looks good. Alright. Now 10C. 10C is a 161, so let's check the enables first. We got a high and we got a pulse, which means it will count. We have that as our load signal. Here's our clock. Very busy clock. We have no clear, so we will have counts on the outputs. There's lowest bit to highest bit. You see how they kind of in sync, you know, they go from smaller to bigger, smaller, twice as big, twice as big, twice as big. And we got our carry bit. So that looks good. 9C, another 161. Same thing. Check the enables first. Okay. Okay, this is a slower count because this is pin 10 and that's an enable. That's a slower count. It will count at that high pulse. And here's our load. And we are not clearing. So let's look at the count. Okay. Good. 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 And alright, we don't have a carry bit at all. But we may not ever have a carry bit. But that could be a problem. Because we are counting. But are we ever terminating is the question before it loads. Because there's no output on pin 15. But we don't know for sure because we don't know if it's supposed to. This is when I like to do the old poor man's comparator. Let me grab a 161. Okay. So I got me a 161 here. And all I'm going to do is I'm going to lift pin 15. Okay. And then I'm going to jump this chip right over that one. And I'm going to see what pin 15 is doing on this jumped chip. And it's not counting. So that tells me that chip is okay and it's just resetting before it terminates. It's loading before it terminates. So that looks good. Okay, back to it. I'm going to cross that one off. That was 9C. Now we're moving to 8E. 8E is a 02. Yeah. The 02 is a NOT OR gate. You have to have either or the inputs. Either of the inputs be 1, you'll get a 0 on the output. So, all right, so we will have a 1 high going signal. So it's basically buffering this signal or inverting it. Yeah, because it's a low, it's an active low. Either one of these is a 1, you'll get a 0 output. So it's inverting that signal. And it will have a signal. We should, I would think. Yeah, right there. Okay. Okay, that's very busy. We are definitely going to have a signal here, like that. And once again, very busy. So we are inverting this signal. And there's that. Well, that one looks good. 8F. 8F is a 10. 3 input, not AND. So you need all of the inputs to have a 1 at the same time to get a 0. So we got 1s there. We got a big 1 there. We have 1s here. And we have an output. Okay. Next, 1s. We got 1s. We got 1s. And we got a signal. Alright. This one's floating, so this is an unused gate. That looks good. 9D is a 161 again. Okay, well, that's the clock signal. That's in one of the enables. The other enable is, okay, and we do have a load signal. Looks like it's loaded, you know, stuck in a load situation most of the time, and then it just comes up to count. So we will have a count, but it will be an odd looking count, and we may not terminate. So there's the first bit, second, third, and the fourth is never counting. So this is the carry bit. Hold up. This is the carry bit. This is the least significant bit right here. Second, third. The fourth bit is high all the time. Let's do a single shot, and it never goes low. This one's never counting. This one's never counting. And you might initially think, well, then if this one's not counting, how in the world can we have a termination bit? Pin 15 has this signal on it right here. Now I want you to look at the load signal. Here's the load. That's our load signal. You've got these low pulses right here. It comes up to count, and then you've got low pulses, right? 1, 2, 3, 4. There's 4 low pulses, and then on pin 15 you have 4 terminal counts, right? You might look at that and say, well, this can't be no good because this bit's not counting. You know, the most significant bit is not counting at all. It's a 1 all the time. If we take let me turn this off so I don't short nothing out. And let me grab this. Let's say that counter is doing this. Let's say it's loading 8 the whole time. That would be the most significant bit. Remember, the most significant bit on that was always a 1. Always a 1. So let's just say it loads 8. That's 8, right? Okay, that's 8. So every time that thing goes low, it loads 8. Here's the load pulse. Boom. It loads 8 into the counter. And then it counts to, it counts up to 15. 1, 1, 1, 1. Then you get this. You get here's pin 15. The terminal count, okay? Now the next time, this counts to 15, and let's just say you keep getting these low pulses, and it goes low, it loads 8, and then it counts 7 clock pulses, or maybe it loads C, right? Maybe it loads C, and then this thing counts 3 times, right? C, A, B, C, D, E, F. It's just gotta do 3 counts, D, E, F, and it's right here. And then you get, while this is F, you get the terminal count. And then it loads again, it loads C again. This thing could just be doing a loop like that. Load C, count to F, load C, count to F, load C, count to F, so that you keep seeing that. So there's a chance, more than likely, that chip is fine, even though it looks goofy like that. So, yeah, that's how that can work. Just depends on what they engineered it to do, how many counts they want it to, how many times they want it to count in what given situation. So, fire it back up, continue with our checks. Now we will look at, okay, that was 9D. I'm going to cross that off because it just doesn't look bad to me. 7P? Is that a thing? There's no 7P. What is that? $7D, maybe. No. I don't know what that is. 7P. There is no P on here. Oh yeah, there is. 7P. It's a 74. We are not clearing. We don't have data. Well, we have low all the time data. We got a clock signal. This isn't going to be doing anything but having a low output on Q and a high output. There we go. Not clearing. We got data. That looks like ROM data. Okay, we got a clock. No clear. And it's high, and this one's low. So it could be that it's just supposed to be that way. That could be an issue. This is our, that looks like tri-stated ROM data or something like that. Who knows? That's something to, I'm going to circle that one because I want to look at that. What is that data line supposed to be? If it's just ROM data, it's okay, then fine, but we'll see. 8H. 8H is another 74, so we are not clearing. That's our data. Looks like ROM data again. Oops, I'm not even on the little scope anymore. There we go. Okay. 8H. Yeah. Okay, we're not clearing. There's our data line again. It looks like ROM data. And we got a clock. We are not presetting. And we're low, and then we're high. I'm going to say that's fine. And then here we are clearing on this side. We have low data all the time. We have a clock. And we're presetting. So yeah, we have a signal here and here. Okay, looks good. 5E. 5E is a 08. Looks good. 6E is a 08. Isn't it? Yep. 74S08. Okay. Looks good. That was 7E, right? No. No, 7E is a 00. 7E. Input, input, out. In, out. In, out. In, out. Okay, and now 7F, which is also a 00. Okay. Okay, I don't see anything. That's all those chips. That's all of them. I want to look at the outputs of these bipolars. These bipolar ROMs. I just want to look at the output bits. Alright. Either that's a 0 all the time or it's... I don't like that at all. Huh, that's interesting. I don't like this bit. I don't. Okay. Good. 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 But coming back to this one, I do not like this at all. It's low all the time, and it's a little spiky. Got little spikies going on. Now we could look at this file and see if that bit is low, is a 0 all the time. See if this is the most significant bit. So it's the second bit. It's 0, 1, 2. Because this is the 1 bit, this is the 0 bit. 0, 1, 2, 3. Yeah, so this is an enable. Yeah, this one I don't like. Don't like it at all. You know what I can do is I have a Star Wars board sitting over on the side, and I can grab this ROM, 112 ROM, and pop it in here and check it out. Let's do that. Let's go real time and remove 112. Okay, let me go remove 112 out of the other board. Be right back. Let's just take a second, hopefully. Okay, coming back. I got chip 112 out of that board. And let's fire it up and look at it. Okay. And it looks the same. So that must be 0 pretty much all the time. This one's a little less noisy. There might actually be a 1 right there. Let's go single shot. Let's move it down. Yeah, I don't know. Yeah, it looks about the same as the other one. So either that, I think that bit is either a 0 all the time, or it's just a, I don't know. I kind of see a flashing higher spike. I'd be interested to see that ROM file, and if those are actually 1s or what. Doesn't look like a clear-cut 1. It could be noise from just the circuit. It could be a 0 all the time. I'd be interested to see that. But that chip's not bad. Let's turn it off. I'm going to go ahead and pop that other one back in it. And throw this back in there. That's not a problem. Okay. So I'm going to go take care, put this one back in the other board, and I'll be back. But all those chips tested good, but we're just going to do a little random poking around on some of the math chips now. Just some random poking without, let's see if we can find something obviously blown out. If not, then we'll have to analyze. Nope, we're back. So we're just going to poke around on some of this stuff. And this is totally meaningless, really, but the only thing you're doing here is maybe we'll find something floating. Oh, excuse me. Low, high. Yeah, these multiplier chips, this means absolutely nothing to me. I find that these multiplier chips, it's easier just to remove them and throw them in my TI 866 logic tester. Okay. And I believe this thing does have a lot of 299. Yeah. Pin 17 of the 299s. And 8. Okay. 299. 17 and 8. Alright, this is a little weird. This is a 299. Floating. Floating, floating. This to me is weird. This is a 299, which is it's a shift register. And I know that this chip is involved in the math circuit, and there's like no activity on it. Floating. This is probably a clock. There's nothing going on this thing. That is a 299 at 3N. I want to look at the schematic and find out what that thing is doing, because there's no activity on it at all. And that's not right. There should be activity. Here's another 299 up here. Pin 17. That's high. Pin 8 is high. Man, this one ain't doing nothing either. It's like got no inputs. These have no inputs. It don't look like. That's clock. Okay, yeah, this is strange. So it's 3N and 7M. 7M and 3N. Oh, well, let's go look at those at the schematic. Okay, 3N and 7M. What chip is... Oh, these are the RAMs. Okay. Let's find those shift registers. They're going to be back. 299 shift registers. 299er. Where are they? $299er. I gotta move over here so I can see. Are these our 299s? They are, but they're not the ones that we're looking for. Those are those multipliers. Okay, these are two of them that were very busy, so I'm not concerned with those. I want to see the other two. Okay. They're right here. The dividend shift register. Dividend shift register. Pin 8 of 7M. 7M and 3N. Remember we had divider errors? This is the dividend shift register. And what is inputting? DD bits. Where are the DD bits coming from? Right here. The dividend latch. See how, okay, let me get the camera. Give you a closer look. The inputs to these guys. This is the, these are the outputs. These are outputting, and then these are DD, no. These latch bits are going into this, and it's shifting these bits. And then this is the output here is shifting this, or is loading into this one. No, because there was no inputs. Remember, there was no inputs. So these are actually, there's nothing being loaded into these. Let's look at that again. Let's look at, what are we looking at? 4, 5, 6, 7. 4, 5, 6, 7, 13, 14, 15, 16. 4, 5, 6, 7, 14, 15. Okay. 4, nothing. 5, 6, 7, what was it, 13? 11, 12, 13, no, 14, 15, 16, 17. And same here, 4, 5, 6, and 7, and 13, 14, 15, 16. Yeah. There's no inputs. And those latches are right here, I believe. No, I don't know where they are. Let's look. Okay. Dividend latch. DD. These are output. See, DB is right here. The quotient shift register. This is being output here. So these 244s are outputting to here. And then these. This is a 374, which is a tri-statable part. So that would tell me that output control is always high. Let's look at 4L and 5L. 4L and 5L. And 4L, 5L. It's these two. Look at pin 1 of both of them. High all the time and high all the time, which means all of the outputs will be tri-stated, will be floating basically. So yeah, you got data input, but there's no output because there's no output enable. 374 is a tri-statable part, which means it can either be high, it can be low, or it can be high impedance or disconnected, floating, not influencing the bus whatsoever. And that's what it's stuck doing because there's no enable control. Pin 9, there's a clock on pin 11, and I bet you there's a busy clock. Oh, there's no clock. We have no clock. So we have no clock, and we have no output control. Okay, and these ones over here, I don't know what circuit these are in. This one's no clock and no control. I'm probing these two right now. I don't know what circuit these two are in. And there's like nothing going on these either. So we've got 4 374s that are not doing anything because they don't have no control signals. They have no control signals. So these 374s here have no control. And that is DVD vector data high, data, where are these signals coming from? Let's go back to DVD, DL, DVD, DH. DVD DL, and DVD DH. DVD DL, DVD DH, DVD SRL. It's this math address decoder. Remember, this is a 7N that I said didn't look bad, but that doesn't mean that it's good. 7N. This guy. So it is being addressed. Remember, this is the first chip that I checked. And then we look at the enables, and it's being enabled. Low enable, and then it's always high, so it basically has two low enables here and here. And the first bit works. There's something there. And there's the next bit. We have another bit here. And we have nothing on that one. Nothing. Nothing. And this is probably the one that pin 9 is probably this signal right here, which is the clock for this. You know, one of them's the clock, one of them's the pin 1. Yeah. You actually have two pin 1s. 7N, this guy. Here's another. $8M. You know what we can do? We can just jump, since these are high, and they may be really stuck high, but we can jump chips over this and look at it. So let's do that. Let's grab a 138 and see what it looks like. Come on. Okay. And let's jump 138. Okay. Let's jump 138 right here. Okay. And then let's look at our output. Is it fighting it? Looks exactly the same. Exactly the same. Exactly the same. And there's no change on the monitor. So I would say that ain't it. We got another one right here. Actually, yeah, that is a 138, isn't it? We got two 138s right there. It will not run with that one jumped. It's kind of interesting to me that it won't run with this one jumped on here. What is this? 8M? I don't know, it doesn't look bad. Apparently that's not the problem, but it's interesting to... This will not run with that chip jumped over it. That's kind of strange. But here we can do this as well. What I want to do is I want to lift pin 9. We're going to do the old poor man's comparator. Put it over 7N. Okay, and look at pin 9 of my chip. And it doesn't look like it's connected. Make sure it's making a connection. Yeah. Yeah, it's high all the time. It's a lot cleaner than the original chip, but it is high all the time. So that's not the problem. That chip is probably good. See, I saved setup time and analyzing time by just eliminating. That's not a problem. That ain't the issue. So the issue would be, why is there no clocking going on there? And I seem to remember this only clocks like once per attract cycle, if that makes any sense. Let's do this. I want to hit single, and let's just kind of see if this goes low. Yeah, see that? It is working. I had it on pin 8. So that is clocking these guys. Now I'm going to do the same thing on pin 1 of those. So I need to put the camera down like so. Put my probe on pin, what, pin 1 was it? Output enable on pin 1 and hit single and just kind of wait and see. And then when it changes the screens is when it does it. So just kind of hold out and wait. See what happens. Hold on just a minute. I think when it changes over to the blue screen, if I can pick this up, when this changes over to the blue, I think the next screen is when it clocks. That's just from memory of doing this on these boards. No, not right here when it turns blue. This will fade out, and then it goes to that blue text screen. I believe that's when it clocks, fires. Now we didn't get anything, but let's wait until, maybe it's at the Star Wars screen. Okay, it's starting to fade out, and we still haven't gotten anything. This isn't doing anything. So that is pin 1 of 4L. Pin 1 of 4L. Pin 1 of 4L is DVSRH. DVSRH. Right there. DVSRH is pin 11 of that 138. Pin 11 of the 138 at 7N. Pin 11 of 7N. Pin 11. So 9, 10, 11. Oops. Pin 11, 9, 10, 11. It's this one right here. This one doesn't seem to be doing anything. $11, $12, Interesting. Okay. I don't think this, I do not believe that this has anything to do with anything. It's just kind of interesting to figure out how it works. It just flashes a low at a certain time. Now, I may end up yet having to analyze these 138s to really and just trigger it on, you know, certain situations and wait and see if it ever triggers, and then if it actually, that's the only way to really know if it really works. So I might have to do that eventually anyway, but for right now I think I'm going to, with these two 384s, I'm going to just jump over both of them and see if I get any change on the screen, because these things are, the only way really to test these is to just throw them in a tester and test them. So I'm just going to jump them and see if that does anything. And then we have some 165 registers here. Yeah, they're very busy. So let's do that. I'm going to take these things and just jump them. I'll be back. Okay, so I have this on now. I'm going to try to stay out of the way so that you can see what I'm doing. You know what I need to do? I need to mute the TV back there. Okay. I'm going to try to stay out of your way. I just got the analyzer out, and right now I've got it set up for LS138s, and there's 3 of them on this board, and we're going to really analyze them completely. And right now I don't have anything triggered. It's just running. And I just got hooked up to this, so we're going to go through them all together. I have not looked at these at all. So what I'm going to do is, right now it's not enabled most of the time. You see 7 up there. This is only enabled when that says 1 is when it's enabled. So right now it's just going along and there's no bits being activated. You can see there they're all 1. And that's what we should see. But now what I want to do is I want to trigger on an enable. So let's go to the trigger and enable on 1. And let's go back. Now we're getting a trigger there, right? We're seeing 1. Let's just stop it. Okay, on this 1 here, it's selecting 1, and the 1 bit 0 1 is going low. That's correct. And then it's back to disabled. Then over here we're enabled again, and it's the 2 bit, so 0 1 2. And you see that there is 0 on the 2 bit, which that's good. And let's just continue to run it. All I really see is an enable on 1 and 2 here. And I know that these things, you have to let this whole thing cycle, but you have to let the attract mode cycle, because some of these things only trigger once per attract cycle. So this is a slow process that you have to sit here and do. What I'm going to do is I see 1, now I'm going to go to the trigger. And I'm going to start trigger on select. I'm going to start with selecting 0. See if this thing ever triggers on 0. And it does, the 0 bit right there. See? You have 1. Oops. It's enabled on 1, and it's selecting 0, and the 0 bit is low. And then when it's not enabled, always check when it's not enabled. It should be all 1s. So that's good. Now what we can do is we can go to trigger it on 1. So go back to the trigger and switch 0 to 1. And now you see the 1 bit. 0 1. So it's triggering on 1. And over here you have a 5, which is a disable, and it's all 1s. And then it's disabled through here, and it's all 1s. So that's good. Over here you have an enable on 2, and the 2 bit is a 0. So that's how we're looking at that. So far so good. Now we will move to the next, make it 2. And we know this, we've seen this. let's just give it a stop. Okay, disabled 2, the 2-bit, and then disabled. Over here we have 1-bit, disabled, 2-bit, disabled, disabled. So far so good. That looks good. No issues. So let's move to trigger on 3. Okay. Now we're just going to have to sit here and wait and see if it triggers 3. I'll let this thing cycle an entire attract mode cycle from where the Star Wars scrolls to it comes back around and the Star Wars scrolls again. And we'll just sit here and wait and see if this thing ever triggers on 3. See if it ever enables the 3-bit. Okay, now we're back to the blue screen, so it does not try to fire that 3-bit. It just doesn't. So we can move on and go to the trigger and select 4. Back to waveform. Now we're going to sit and wait and see if it triggers the 4th bit. And right now Star Wars is scrolling up on the screen, so I'm going to wait until it gets back to that. Just sit there and wait and see. So I'm triggering on the enable being 1, which is enables everything. And I'm triggering on the address input being 4. I'm trying to see if it ever enables and fires the 4-bit. So far, no, because the Star Wars is coming back around. So no, it does not. It doesn't do that. So now we're going to move on to the 5-bit. I'm pretty sure I saw the 5-bit. Sometimes, every time you change the trigger, you got to stop it and restart it. Now we're going to wait for the 5-bit. Same thing. Star Wars just scrolled. So now we're going to wait for it to come right back around to Star Wars. And nothing. No 5. No enable on the 5-bit. Okay. So let's go to the trigger and see if it enables on 6. Okay, so it does enable on the 6-bit and the 7-bit here. So that is the 6-bit right there, and that is the 7-bit right there. Yeah. You can go, let's just do a single shot. And the next time it does that, you'll see it. And this waiting screen right here, this waiting text, that'll disappear once it does fire that 6. So it does fire 6 and it does fire 7. And those seem to be fine. Those are working. So this chip does not have an issue. Okay, there's the blue text. It just switched over to the blue text screen and fired those two. Let's see if it does it again once that fades out and the Star Wars scrolling starts. Let's see if it fires 6 and 7 again. It does. So, yeah, okay. That chip's fine. So now we're going to clear the trigger. Completely clear it. Go back to the waveform. Repetitive run. And I'm going to go to the next 138, which is right here. Okay. Now I'm on the next one. And I don't see, I'm not seeing, well, I'm seeing some business up there. But right now it's disabled and it's ones all the way across. So that's what we should see. We shouldn't see any zeros when it's not enabled. So we will go ahead and, oops, go to the trigger. Let's trigger on 1. So this is going to be, okay, we have 2-bit here. 1, 2. That's good. 4-bit. 1, 0, 1, 2, 3, 4. That's good. 2-bit. So let's do like we did with the other one. Let's start with 0. Start with the 0-bit and see if it does fire the 0-bit. See? And we can go repetitive, and it's just over and over and over that fire in that 0-bit. Okay, so that looks good. Now we'll go to the 1-bit. And let's just hang out and see if it ever fires that 1-bit. Okay, it just went to the blue text screen. And after the Star Wars screen comes up, I'm going to stop recording and I'm going to do the rest of these off camera. And I'll let you know if anything fails. That's fading out now, and here's the Star Wars screen, and it does not fire that 1-bit. So I'm going to continue to do this, and once I get done with the 138s, I'll come back. Okay, I've decided to go ahead and start looking at the 165 shift registers that are in the math circuit, the matrix circuit, I should say. And in the past, I have found that these 165s fail quite often and cause these very problems in the matrix processor. So I'm starting with the 165s. And these are something that you just have to analyze. You know, either that or you just guess and replace them and hope that they're right. Hope that you were right, you know. But we're going to analyze them and actually look at how they're working. And I'm on one of them right now, and I'm looking at it, and we're going to see if it's doing what it should be doing. And the easiest way to do this is to write down what you see. I'm going to just go ahead and do it repetitive. What I like to do is make it small like this so I can get a good sample section of what's going on, and just kind of try to catch it like that. I got a lot of clock pulses here. I need to mute the Waltons really quick. And then you can expand it a little bit, right, to about right there. And I want to back up. We have here's a load pulse. Now this thing loads right there, and I want to actually start right there. So it loaded 1110 1110. So I'm going to write that down. 1110 1110. Okay, and this is right here. Right? 1110 1110. A through H. This is the most significant bit. That's the least. 1110 1110. So I write it down, and how this thing works is with every clock pulse, it will shift from A towards H. So basically what we're going to see is, I'll do this: clock pulse 1, clock pulse 2, 3, 4, 5, 6, 7, and 8. And what will we expect to see on QH? Okay. QH is going to be at 1. And it is. It's at 1. See that? QH is at 1 until we don't have any clocking yet. There's no clock pulses. So it loaded this number, and QH is actually what H is, and H is a 1. So QH is 1 this whole time because there's no clocking going on. This is loaded internally into that flop. So this is the H bit right here, 1. QH is the same as H. That's important. It's not like it shifts the 8 bits out and then QH is separate. It may be separate from internal H, but it's the exact same as internal H. I know this sounds kind of confusing, but just think of it as QH is the same as H. They are one and the same logic state. So when this loads, the H bit is 1, so it becomes 1. Okay. Now we're going to, okay, QH on clock pulse 1 is going to stay here. This is how I should do it. I should do this. Yeah, hold on. I'll be right. Hold up. Let me change something. This is what we should. Okay, this is how this is what we should see. Let me try to do this. Okay. Boy, this is tough. Everything's backwards. Okay, so QH. This is what was loaded in. QH idle state will be 1 because that's without any clocking because H is 1. Clock pulse 1, we should see a 1. Clock pulse 2, it'll stay a 1. Clock pulse 3, we'll get a 0. And then for 4 clock pulses, we'll get a 1. And then the last clock pulse, it will be whatever is on serial input. Okay, so if we look at this and we scroll it over to our clocking, now it starts clocking, and I like to bring it over right to the edge. Here's our first clock pulse. And remember what I say it should be, clock pulse 1 and 2, we get 2 1s. So here's clock pulse 1, it's still a 1. Clock pulse 2, it's still a 1. Now clock pulse 3, you'll see it goes 0. So here's clock pulse 3, QH is now 0. See that? Now clock pulses 4, 5, 6, and 7 are 1. So we got 4 pulses at 1. Okay, so here's 1. And it's 1. Second pulse, 1. Third pulse, 1. Now fourth pulse, it goes to 0. Yeah, because that's correct. Because these are our 1, 2, 3, 4, 5, 6, 7, and yeah, because we only have 3 1s here. Those 3 1s are getting clocked. And there's our 3 1s right there. And then this is our serial input. So this is our first output. There you have 1 1 1 0 and 1 1 1 0. That got shifted through. If that makes any sense. And then it's just 0. It stays 0 the whole time. And we'll look at it again. We'll look at another one. Just find some clock pulses. There we go. Kind of zoom it out. about like that. And I see, okay, here we loaded. Let's see what we loaded, and now we got a shift. We loaded 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0. Okay, now we loaded this 0, 1, 1, 1, 0, 1, 1, 0. This being the A bit, this being the H bit. So our idle state is going to be a 0. Okay. And clock pulse 1, it'll go to 1. Clock pulse 2, it'll stay 1. 3, it'll stay 1. And then it'll go to 0 on the 4th pulse. The 5th will be 1. 6th will be 1. 7th will be 0. Okay. So if we look, this is what we're expecting to see. There's our 0, 1, 1, 0, 1, 1, 1, 0. 0, 1, 1, 0, 1, 1, 1, 0. That's what we expect to see. So if we scroll over to the first, our idle state is 0. When it loaded that, H is 0, so it's 0. Now we come to our first pulse, and what did we say it would do? First pulse would go 1, and we've actually got 3 1 pulses. So 1, 2, 3, and then our 4th pulse is a 0. Okay, 0, and now we have 2 pulses at 1, 1, 1, and then a 0. So that, and then it just stays 0. So that's how that works. Now I'm going to go ahead and off camera look at the remaining 3 of these, and we'll see if I find anything, I'll come back. Let's put it that way. Alright, I'll be back. Okay, so I just went to the next one and I'm analyzing it, and you'll see this one isn't doing anything. We just analyzed one that was obviously doing what it should do. Now we look at this one, and this one isn't doing nothing. So, and my battery's about dead on my camera. Anyway, just like that one, and I've got this one wrote out. We have a load pulse here, and we're loading 0, 1, 1, 0, 1, 0, 0, 0. 0, 1, 1, 0, 1, 0, 0, 0. So our idle state is 0. First clock pulse will be 1, second 1, third 0, fourth 1, and then 3 zeros out. Right? Okay. So we load that. So our idle state on QH is 0, so that's good. Scroll over to our first clock pulse here. It should go to 1 and it stays 0, and then it should be another 1 and it stays 0. Then it should go to 0, then it should go to 1, and then 3 zeros out. See, this one didn't do anything. This one's definitely no good. There's actually no action on that chip at all. So I'm going to go ahead, put a red dot on that guy, and move on to the next one. Okay, this one's a little confusing because you got a couple of things to consider. Number one, it loads 0, 0, 0, 0, 0, 0, 1. So it loads 0, 0, 0, 0, 0, 0, 0, 1. That is A, that is H. Okay. So we're going to have 1, 2, 3, 4, 5, 6. Our idle state is 0. and then we'll have 1, 2, 3, 4, 5, 6 pulses of 0, I mean. So clock pulse 1, 2, 3, 4, 5, 6. Okay, so we should have at the clock pulses 6 zeros. So here's the first one, 2, 3, 4, 5, 6, and then the 7th it goes to 1. So let's back up. Here's the first clock pulse right here. So we have our 1, 2, 3, 4, 5, 6, and then we have our 1 on the 7th one. Now we have to also look at what is being shifted in. So let's make another column called shifted in. Another column called shifted in. So we know our zeros are good. So let's just look at what's shifted in. First pulse. Here's the first pulse. It shifts in a 1. Here's serial in as a 1. So the least significant shift in is a 1. The next pulse it shifts in another 1. The next pulse it shifts in another 1. The next pulse it shifts in another 1. Now it shifts in its 0. Now it shifts in another 1. You can see this is high right here. And then it shifts zeros the whole time. So 0. See, I have that here. Shifted in 1, 1, 1, 1, 0, 1, 0, and then all zeros. So that's what gets shifted into this thing, and we need to take that into account. So now we can back up and go back to that first pulse to our 6. 1, 2, 3, 4, 5, 6 0 shifts. 1, 2, 3, 4, 5, 6. And then we have this bit right here gets shifted, that 1. And that's right here. At this pulse it goes to 1. Okay, and that was the last bit. And then we have our shifted in bits, which actually, this is backwards. It should be this way. 1, 1, 1, 1, 0, 1, 0. It should be like this. 1, 1, 1, because these are coming this way. Remember, from A to H, this way. So we're going to see 1, 1, 1, 1. We're going to see 4 1s, and then we're going to see 0, 1, 0, and then all zeros. So we should see 4 1s. And you can see right here we have a big block of 1. So it should be 4. Starting with this pulse 1, because remember this is our pulse right here. That's this one that was already loaded into the register. So once that one is shifted, now we have these 4 1s. So we have 1, 1, 2, 3, 4. That's the 4th one. Now we have 0, 1, 0. So we have 0, it goes 0, and then back to 1, and then back to 0, and it's all zeros, because this is all zeros. So that is kind of it's kind of complex, kind of complicated, but you have to write it out. You have to write it out and actually see what it's doing to analyze this. But that one I just analyzed is working fine. So I'm going to go ahead and continue and move on to the next one. That's 3 out of 4. So far, 1 of them is bad. Now I'm going to check the 4th one. Okay, I'm looking at the 4th and last one really quick because my battery's going to die. Shift in, you can see right here, I'm going to scroll, is 1, all of these pulses, right, forever. And that kind of tells you right now that this thing isn't working. Because if you look at, it's shifting a 1 in on each of these pulses. So every one of these pulses, this should be high the whole time, because it's shifted ones in this whole time. That tells you right there that this thing isn't working. But you can see it loaded 0110 1101, which is right here, 0110 1101. That's what it loaded. So our idle state is that H0, and then with the first pulse at H we'll see 1, then 1, 0, 1, 1, 0, 1. So that should be first pulse 1, 1, 0. First pulse, okay, 1, 1, 0. That's right. Now we have two ones. 1, 1. Now we should have 0, and we do. Now it should be 1 again, and it's not. And then it should be 1s the whole time, because all those 1s got shifted in. See, serial in is 1 this whole time. Now it should be 1 the whole time, and it's not. So that one also is no good. The battery is dead. Alright, well, sorry about that battery dying, but yeah, I think we got the gist of, these are the chips that we were looking at, the 165s, these shifters. And you can see right here, it's all in the serial multiplier accumulator. It all is part of that circuitry in the math box, the yeah, that type of stuff. Anyway, these were the two that were bad, 7A and 7B. And coincidentally, those are the two that are actually starting the whole, you know, circuitry here for the serial subtractor, subtracting, however that thing, whatever that's doing, you know, whatever. So replaced those two guys, and then off camera, since the camera died, I started on this page right here. I looked at these 175s with the little scope, actually, because they're easy to just look at these signals. They were all good. I moved on to the adders, and this guy right here was no good, 6M. And what that does is it produces the lower 4 bits of the data from this difference latch. Produces DD 0 through 15. So yeah, that one was no good right there, and I replaced it, and then I got no more errors, and we are rolling. So I'll do a quick put the camera on tripod and do a quick gameplay and call it good. Yeah, no divider errors, no matrix errors, and I just had to come in and straighten the BIP line. The BIP pots were way off. Now you can see I can scroll through and everything looks good. Yeah, this where it says BIP test, align the boxes, was way off. So linear test is good. Let's go back to that linear test, because it does, then it'll do a binary test after this. And it stops, and then it goes, and it stops. Yeah. Oh, that's looking good. Let's take it out of test. And we should be ready to play.
The force will be with you.
Yes, yes it will.
Red 5 standing by.
I trust you, Ben. Obi-Wan. Force will be with you.
R2 trying to increase the power. Good 5, I'm going in.
One more hit, I'm dead.
Remember, the Force will be with you, always.
Yes. Thank you, Ben. All right. No, I'm curious. Let me take a look at that as well as over here. This one that I recently repaired. That looks like the same. Let's take another look. Okay. Is that the same rings? I think so. I'm just wondering why this thing has color distortion over here. I'm not exactly sure. It's the tube. It's not the electronics. It's something with the tube or the magnets or something. Something's not right on there. I don't know. Anyway. Yeah, so what did we do? Remember, we had a blanking issue and the DAC fixed that, replaced these two regulators. All of the RAM were bad. All 6 of these RAM were no good. This chip was bad, giving all kind of erroneous errors in test with the RAM and the ROM, and it turned out to be this guy. Replaced this one as well, but it was actually this one was the culprit. That was it for this board. This board we had under test, we had matrix errors and divider errors. The matrix errors were these two guys right here. I accidentally removed this chip, which is another one of those 165s, so I actually replaced 3 of them. These 2 were the only ones that were bad. These 2 guys right here. That fixed and cleared the matrix issues. The divider issues were due to this 83 adder. So that was that. Remember the old rusted out 191s? I replaced all 6 of them. 1, 2, 3, 4, 5, 6. They were all rusty and crusty and nasty. That's that. The RAM is right here. That's the RAM that goes in there. Always remove that when doing testing. It doesn't need to be there. Okay, so that is it. Nothing wrong with the soundboard. So this board had issues. This board had issues. That's it. Another Star Wars fixed. Here's the this board right here. I'll give that an inspection and I'm sure it'll be fine. I'll just inspect it, probably reflow the solder on here, clean it up, that'll be good to go. And another Star Wars board set, fixed, saved. Alright guys, that's it. Hope you enjoyed part 3 of this. And we'll see you all on the next Classic Arcade Repair. Bye for now.